Hello, ninth graders. We are moving on today from factoring. So this unit deals with two main concepts. The first one being factoring, which we spent a lot of time on, and the second one that we're dealing with is radicals. This is all leading us to information that's all going to be really helpful and used a lot in our next unit, which is solving for quadratic equations. So we need to know how to factor in order to do that. And we also need to know how to deal with radicals because we're going to be dealing with them a lot in our next unit. So just really quickly, we're going to talk about simplifying radicals. So the main idea with simplifying radicals is you want to find a perfect of whatever that radical is inside of it. So you can see that here we've got square roots. If you don't have any number that's in front of this guy, that means that it's a 2. It's called the index of the root. It's a 2 if it's invisible. So we have a couple of those things that occur. If you don't see an exponent, the exponent is 1. If you don't see a coefficient, the coefficient is 1. So coefficient and exponent, right? If you don't see anything being added, it's just 0. If you don't see the index, it's 2. If you do see the index, it is that radical. So for instance, this is a cube root that you could, which means it's the undoing of a cube. So with a square root, we are looking for perfect squares that go into 32. We're looking for factors that are perfect squares that go into 32. Now 4 definitely goes into 32, but it is not the largest one that goes into 32. But let's talk about this for a second because you might make this mistake in the future. So let's say, for instance, you thought, oh, well, 4 is a perfect square and it goes into 32. So you're breaking this down into the square root of 4 times 8, which you can totally separate those guys out and becomes the square root of 4 times the square root of 8. Square root of 4 is 2. Make sure to take the square root when you take it out, and you're left with the square root of 8. Now, however, is it fully simplified? No, it is not, because 8 has a perfect square that goes into it, another 4. So then I can take 2 and then separate it out as 4 times 2, which means it becomes 2 times the square root of 4 times the square root of 2. Square root of 4 is 2. You have to multiply it to that 2 in the front. So you're left with 4, because 2 times 2 is 4, and then the square root of 2 on the inside. So you can absolutely simplify radicals by baby steps. If you're like, oh, will a 4 go into it? Will a 9 go into it, right? And then move forward from there. But let's say, for instance, that our perfect square, if you saw that 16 was the perfect square that came out, fantastic. But you don't always have to see it. You can always do baby steps. Just make sure to multiply when you take them out in the baby steps. All right. I would like for you to try to simplify the square root of 45 on your own. Notice that 45 has a perfect square. The perfect square is 9. 9 will come out to become 3, and we're left with the square root of 5. Try number 3. 100 is our perfect square that goes into 300. Maybe you noticed 25, maybe you noticed 4, and you tried to do some baby steps. That's totally fine. But 100 is the largest perfect square that goes into it. So if you factored out all of the baby steps correctly, you should have ended with 10 square root of 3. The next thing that I wanted to talk to you about today is when we have we're raising a square root to a square. And when we're raising a square root to a square, it just undoes that thing, right? So the square root of 14 squared is just 14. This is also equal to, if I were to do 14 squared and then take the square root, that would be the same thing. It doesn't matter if the square is inside or outside. If they're happening together in the same situation, then they are undone. However, if there's a plus or minus in there, it all gets messed up. Pluses and minuses always ruin all of these rules. So just be aware that this only works if you have this guy looking like this, or if there's like a multiplication happening. Okay, So we're going to practice this a little bit. Notice here that we've got this fraction squared. Your exponents need to be applied to both the numerator and the denominator. Kind of the same idea as distribution. It can happen here where we're distributing the exponent because it is a division happening. We can do it with like multiplication or division. We just can't distribute those squares when there's an addition in between. So remember, like your x plus y squared is going to be x plus y times x plus y, not x squared plus y squared. Because there's that plus in the middle, it messes everything up. But if it's just multiplication and division, you can absolutely distribute those squares into those pieces. So we're distributing the square into these pieces, and we've got 2 squared divided by the square root of 8 squared. So 2 squared is 4, and as we talked about in our previous example, the square root of 8 squared is just 8. This is going to simplify down to 1/2. All right, I would like for you to do 6 on your own. This is really just what 4 was up above. We've got a cube root and a cube. They undo each other. This would be the same thing as if I did 7 cubed on the inside and the cube root of 7 cubed on the inside. So the idea here is that it is just 7. It just gets rid of everything. Okay. So we have got something being multiplied squared, which is great. We can think about it as 3 times the square root of 2 times 3 times the square root of 2, right? So then we take these 2 3s right here and multiply them together, and we're left with 9. And then we've got the square root of 2 times the square root of 2, or in other words, the square root of 2 squared. The square root of 2 squared, it just undoes all of that, and all we're left with is 2. Now it is being multiplied to 9 here, so we do need to make sure that we multiply those 2 together to get 18. So a few things to watch out for here is that you need to distribute that squared both to the 3 and to the square root. We can do that because it's being multiplied. So we need to make sure that we square 3 as well. And so that's a common mistake. And then we also need to make sure that when we finally square both of these pieces, that we then multiply both of those resulting pieces together to get your final piece. So go ahead and do 8 on your own. So we get 2 to the 4th power times the square root of 6 to the 4th power. This was a little bit tricky, but hopefully you found out a few different ways that you can do this. You could have either figured out what 6 to the 4th power is, which is like 36 times 36. It's a big number. Or you could realize that that is the square root of 6 squared. Raising an exponent to another exponent results in the multiplication of those. So kind of puzzling it out maybe a little bit, you could realize that raising this guy would become the 4th power. The square root of 6 squared then just gets rid of that, and it becomes just 6 squared, right? This guy and this guy cancel out, so you're left with just the 6, but you still have this other squared that's going on. 2 to the 4th power is 2, 4, 8, 16, right? And then 16 times 6 squared, which is 36, is 576. Okay. Number 4, we again have these pieces being multiplied together. You can kind of see we did this up above here. So what you need to do is you need to multiply the coefficients together. They're the pieces that go together. And then you also multiply the square root of 5 together. So I think about this in my head as 2 times 4 times the square root of 5 times the square root of 5. Which results in 8 times, and the square root of 5 times the square root of 5 is like the square root of 5 squared, so it's just 5. And our final answer is 40. Okay, we have 4 more problems that I want for you to just simplify. This is the main idea that I want you to get out of this of these notes. There's a lot of different ways that you can simplify them down. Our next notes are going to be using operations with radicals, and so just being able to simplify radicals down is going to be what's the most important thing here. So I want you to do all 4 of these on your own and tell me what you get. So for problem 10, what we need to do is we need to find a perfect square that goes into 98. And I'm going to do baby steps here because I know that 4 at, oh, wait, never mind. I don't know that 4 is going to go into it. 98 divided by, so I tried 98 divided by 4 and that didn't work. 98 divided by 9 wouldn't work. 16 wouldn't work. 25 wouldn't work. I wonder if 36 would work, which it doesn't. And so I think that the square root of 98 is just the square root of 98. I'm going to double check real quick by making a factoring tree. So a factoring tree is when you have these numbers, you take a number and you say, okay, well, like what numbers go into it? So I'm going to first factor out a 2 and I'm left with 49. And there we go. That's what it is. And then 49 is 7 and 7. So if I see a prime factor, so when you factor it all down, you'll notice that if a prime factor occurs twice, then a perfect square goes into it. So for instance, with 32, we've got 32, 16, 2, 4, 4, 2, 2, 2, 2. We've got a prime factor occurring 1, 2, 3, 4, 5 times. 2 times 2 times 2 times 2 times 2. 2 to the 5th power is 32. So if you break down a number into all of its prime factors, I wonder when the last time you saw this was. I bet you've seen it before in a class. If you see a prime factor occur more than once, then you know that a perfect square goes into it. So I was stuck. I couldn't think. I was like 49. I didn't even think about 49. I stopped at 36. But if you break down a number into all of its prime factors, it's a good way to just do a quick check of, is there a perfect square that goes into it? Which there is. It becomes 7 times the square root of 2. Your 49 comes out. Square root of 49 is 7. And you're left with a 2 on the inside. For problem 80, we have 2 and 40, and another 2 and 20, and then another 2 and 10, and then 5 and 2. So I noticed that 2 to the 4th power occurs there, which means I think 16. Yeah, so 16 goes into 80. So we're going to do the square root of 16 times 5, which is 4 times the square root of 5. 2 times 2 times 2 times 2 is 16. That's the perfect square, and that's how I knew. For problem number 12, the perfect square that's going to come out is 9. So I get 4 times the square root of 9 times 2. That 9 comes out and becomes a 3, and it multiplies with that 4. So it becomes 12 times the square root of 2. 275, I know, has at least a 25 that comes out. So 3 times, and it's 25 times 11. And 11 is prime, so we're going to stop there. The 5 is going to come out and multiply to the 3 and become 15, and we're left with the square root of 11. Okay. So it's not perfect, as in like you won't always know exactly what to do, but you've got a lot of strategies and a lot of ideas going on here of which you could solve it out, whether it's a factor tree, whether it's just testing like your perfect squares are going to be 4, 9, 16, 25, 36, 49, and so on. So testing those all out, just making sure that the number that's left inside has no more perfect squares that go into it is the important part. And that is simplifying radicals.